Hi there. In this video we're going to be doing a question on tangency. The question we're going to be doing on tangency is a doorknob. This is the question. Everything in this drawing is going to utilize concepts on tangency. The key to this question is understanding that there's a lot of symmetry. By symmetry, what we just mean is there are a lot of parts that are the same. For example, if we take this line here, we can see what's above the line is the same as what's below that line. In addition, these lines of symmetry here are actually center lines. This line here is having a long dash, a short dash, a long dash, short dash. Hence it's a center line. Similarly, you can see on this other line here, it's also a long dash, long, short, long, which makes it also a center line. These two lines here are also center lines. Understanding what these center lines are trying to tell us is very important. This mid center line here is telling us that whichever distances are marked in this drawing, for example the 80, the 94, the 34 and the 52, can be divided into half. Because it's a center line, it's in between these distances, this one and that one. So we can confidently say that if we wanted to find the distance from this center line to this point here, we can just get this distance 52 and divide it by 2. If you do the mathematics, that should be 26. So the distance from here to there is 26. The distance from here to there is 17. The distance from this point to this point is 40. The distance from this point to this other point is 47. Understanding just this will help you start this drawing. Other distances are given here. The R55, which is just an arctangent, which is touching this circle here. You notice this arc does not have any measurement, but because we've got symmetry in this drawing, what's on top is the same as what's at the bottom. We can confidently say that this arc here is the same arc as the one that's at the bottom. Therefore, this arc here is going to be 55 millimeters. The same applies to this circle here. You can see that there's no measurement given, but because of symmetry, this R16 will also apply to that circle. Whenever you're undertaking questions about tangency, it's always good that you do the simplest things first. So the approach will be just something simple. I like writing it down like this. So when you have a question like this, what you just simply do is, first, locating your center lines. Step 2, you draw, we can call them important circles. Next, locate important points. You will later see what that means. This can be, for example, points of tangency. After that, you draw your tangents. And the most important here is step 5. You make sure you draw a clear and neat outline. So these are the 5 steps we can take. They can be more than this, we can have multiple things, but this is the general steps that we will take when answering questions on tangency. You need to locate the center lines. For example, here we've got this center line, this one and that one. We do that first. Then we'll draw important circles, locate important points, draw our tangents, then we draw a clear and neat outline. So what is an outline? The outline is just this shape that we're seeing. After we're done drawing, only this shape here that we've been given is supposed to be outlined. So let's get started with locating our center lines. The first center line we're going to draw is this one here, which is going through the whole drawing. We'll just draw it somewhere on our drawing paper. Should be in the middle of your paper likely. So you get your T-square and then you draw a line that is a center line. When starting, you can just draw a construction line like this, or preferably you can draw the actual center line in advance. So you have a long dash, a short dash, long dash, short dash, like that. So we have our center line. After we have our center line, we can draw this center line here at any position. You notice we haven't been given any distance. Yes, we can say we have this 70, but we can draw this center line at any point such that it crosses this first center line. We can draw it here, there, wherever, but it's best to draw it on our right part. So I have my T-square like this. Then I'll put my set square. I make a 90. Then I draw my center line, short, long dash, this same short dash, and the longer dash like that. Now we are going to locate our centers for the circles. If you look clearly, we have the distance between these two center points. It's 94. Now because we have this center line that was just from drawing here, we're going to mark half of 94 on top of this center line and half of 94 below it. 94 divided by 2 is 47. Mark at the top, and at the bottom like that. These points are also having center lines. So I'll draw a short dash, long dash, another longer dash this side. Similarly at the top there, short dash, long dash, another longer dash. So I have my outline of the points where I'm supposed to have circles. I've located this point and that point. Now I can draw circles. You notice we don't have any other circles. This here is not a circle, it's more of a tangent than a circle. So it's only this one and this one. We already know that this one is a tangent, so we'll just draw these two circles of radius 16. Stand at this point, draw a circle. This circle is not going to be outlined, it will just be in construction. This one will also not be outlined, it will be just in construction. If we look at our drawing here, which are our important points? If we're going to say that this here is a tangent, then we need to locate this point here where this tangent is touching. Similarly, the point there. So that's an important point. On this part here, we also need to locate this point here and this one here, because they are going to enable us to draw this arc here, which is a tangent to this point and that point. So let's go ahead with starting with these points here and then coming to this here. If we look at this here, the distance from this point to the point we want to plot here is half of 34, which is 17. So we'll get 17 and mark it from here to there. Now when we come to our drawing, you will see that we don't have that line on which we are marking the 17. We need to go back to our drawing and check what is the distance from this center line here to that point where we're going to mark the 17 millimeters. If we check on the drawing, it's not very difficult. We've been given this 70 millimeters at the top. You can see it from this center line here, which we've just drawn, this center line, and going all the way to the left to the line on which we're supposed to mark the 17 millimeters. So we'll first mark our 70 millimeters. So I've picked my 70 millimeters from a ruler. I mark it like that. This point here is my mark for the 70. Then from that line, I'm going to erect a vertical line. You notice we didn't have a center line at this point, it was just a line. Then on this line we're going to mark a 17 millimeters. So I pick 17 millimeters, mark it at the top like that and at the bottom. So this is an important point because it's the point where we're having a tangent to the circle. So in this question, we're dealing with a simple arctangent. It's an arctangent to a point. We've been given the radius here. What we need to do is locate the point at which we're going to strike with this radius. So I'll mark it. We need to find a certain point here. How are we going to do that? Well, from concepts that we've learned on tangency, we can see that this tangent that we have here is bulging towards the circle. If you can't see that, I'll just draw a simple sketch here so that you can follow easily. So we've got a circle like this. We know its center and we know its radius. Then we also have a point like that on which we know that there's going to be an arctangent that will come like that. So if you look, the curvature of this circle is bulging towards the circle. It's different from a case when we have a circle like this and then a point like that. You can see that the curvature of this arctangent is bulging away from the circle. So when we see that this bulging is towards the circle, we need to remember that we're going to add the radius of our circle. So r circle plus r tangent. We add these two. This is going to be equal to, so if you get r circle plus r tangent, this will give you the distance to the center of the arctangent. Now, where are we going to stand to get that distance? We're going to stand on the center of the circle. So if we add our distances, we're going to be adding 16 and 55. If we do the quick math, that should give us 71. So I'll get 71 and mark it on our drawing. Okay, so after we have drawn our 71 millimeters, we have marked possible line in which our point, our center for this arctangent is going to be. The next thing is we need to mark another distance using the other point where this arctangent is touching. The arctangent is touching this circle and these points here. If you can remember, we marked them. It's this point here and this one here. Now for these, because they are just points, they are not a point of tangency that is coming from a circle. They are different from these other ones that we are drawing. We had the formula that we kind of used just some minutes ago. We said the distance to the center of the arctangent is equal to r circle plus r tangent. Now, when we have a point, we don't have the radius of the circle that we're supposed to use. So we'll just forget about that r of the circle and we'll use the radius of the tangent. So when we're locating the center of the arctangent coming from a point, the distance to the center of the arctangent is equal to the radius of the tangent. That means we'll just get r55 as it is. and stand at the required point. We pick 55, then this is the point where the tangent is going to touch, so we stand there with our compass and then mark an arc. We'll have an intersection with the area arcs that we drew. So now we need to draw our normals. Remember, these are tangents. We can draw a tangent without a normal. So from this center of the arc tangent to the center of the circle, we'll draw a line like that. Then from the center of the arc tangent to our other point where the arc tangent is going to touch, we also draw a line. We do the same for the part above. And now we have our points of tangency. If you can recall, our next step was drawing our tangents. Because we have drawn our circles, we've located our important points, the points of tangency. You can see that step 4 is involving us to draw our tangents. So let's do that. Our tangent has a radius of 55. We can measure the 55 and then stand at this point and mark, or since we know we've used correct geometrical methods, when we stand at this point and open to this point of tangency here, we should have 55. Just before drawing, it's a good idea that you test that it's touching both points, then you outline. We do the same for this other part in the bottom. Before we draw, we just test it's touching both parts, then we outline. Whenever you're drawing such questions, you make sure you are very accurate, otherwise your tangent won't touch the correct point. As you can see, the arc is only touching at this point here. That should be the case even in your drawings. The next part now is drawing the other tangent that we can see. We can see another tangent here. This is a tangent, but due to how it is, we can just think of it as a straight line. So we'll join this point and this point, and we'll have that part drawn. Let's also draw the tangent here with a radius of 66. So this time we're not drawing a tangent between a circle and a point. In this case, we have 2 points. So there's a point here, there's a point here. We had the formula area, and that was just from saying that if we don't have a circle involved in the tangency of an arc, we can ignore this R circle and then remember that the radius of the tangent is going to be equal to the distance to the center of the arc tangent. So if we want to locate the center of the arc tangent of radius 66, we first need to locate these 2 points. Then we stand at those 2 points with a radius of 66 and then mark 2 arcs. Where those 2 arcs are going to intersect is where our center is going to be. The points of tangency, or the point where that arc is going to touch, they are 40 millimeters away from the center line. Hope you can see that. There's this 80 millimeters which is between the 2 points. And remember, earlier starting this question, we emphasized that this center line is showing us that to get the distance to that point, if we start from this center line, we'll just pick half of 80. So we'll pick 40 millimeters because 40 is half of 80. Stand at this point, then strike an arc like that. Similarly, at the bottom, we strike another arc. So these 2 are the points of tangency. Next, we're going to measure a radius of 66 millimeters. Why? Because that's the radius of the tangent, which is equal to the distance to the center of the arc tangent. Then we'll stand at the point of tangency, mark an arc like that. On the other one, we mark an arc also. For this question, the center of the arctangent is actually on this center line, which is something you should have expected because this again is a symmetrical object. You can see even from how they've placed the 66, they are showing us that it's somewhere on this center line. There's no distance. So this is the way we can locate it. Then we'll need to draw our normals because this is a tangent. You can draw from this point here. And then we get our radius 66. We stand at this point, open like that. You can see it touches at that point and this point. So we just now need to outline. Like that. So we've drawn all our tangents and we are done with this question. The only part that remains is outlining. Remember, step 5 told us that we need to draw a clear and neat outline of the drawing. Now, which other parts are remaining if we look at our drawing? You can see the only part remaining is a simple rectangle on the left part. And I am sure you know how to draw rectangles. This rectangle has a length of 52 and a breadth of 9 millimeters. Again, you notice that we're not going to mark the 52 directly. We'll get half of it, stand on this center line, and mark that distance. The distance we're supposed to use is 26. So we get 26 millimeters. Stand at this point. You can strike an arc like that. Another one. Then from these lines that these marks that we've drawn, we can draw extensions like that. You can see we have 2 extensions. Then we can draw a 9 millimeters from this point to the left. So this is our 9 millimeters. Notice I'm using a T-square here, so I'll just slide it a bit to the bottom, use a set square, place it on my T-square, and then outline my length of the rectangle. And our circle at the bottom. This is how we could do this question. You can see it's very simple, but it enables you to revise the important concepts about tangency.